I'm sorry to hear that.
I do a lot of back-end stuff, so this is like completely new to me. It's so hard.
Okay, welcome. We are officially recording already, but the class, is in a couple of minutes. Let me. Okay.
So I remember it was not displaying the HTML.
Yeah, it was. Oh, yeah. I remember why. Because we had the if all user is none in the brackets here, and then we had another pass here, and then I tried to comment it out, but then this thing told me that you can't comment those out. So I just deleted it entirely, and now it shows. Yeah. So I pretty much finished this.
Yeah, I think still parses, or still looks for those granny prices to in Python, even if it's commented out.
Yeah.
I ran into an error with that the other day, and I thought it was funny.
I didn't know. So then that just told me, and then that was something. So yeah. I think I pretty much finished this now. I already submitted it. I'm gonna go through this whole thing, comment everything, so I know how to
You feel like you understand how it works?
Yeah.
Nice.
And then for like
Probably rename your database table.
yeah. I'll have to do that very slowly.
Okay, maybe let's start. So while you all check in, some general comments. Of course, so I don't have a uniform sample of what people do in the class. Maybe I will have it via this query, but I wanted to give you some general advice. One is don't rely just on the code I post at the end of each class. Look at the book, right? You're not able to really do well in the class if you just follow what I do. What I do is kind of an introduction to the various things you should be able to do. And I try to, give you as good as introduction as I can, but there is more material in the book, and you're supposed to be able to look at it. Okay, so if you don't know how a form is generated, if you don't know how to generate forms with a SQL form, definitely you need to be able to look into the book. Okay. A related comment is this. This year I decided that for the homework I would give you, in the years past I would give you always, I would give people starter code. And this facilitated the homework, but also made it so that I'm not sure that everybody knew how to, get to the homework from zero in the end. And so what I'm doing now is to tell you to do the homework from a clean branch. And of course, you have access to everything I've ever done in class. And for example, I was a little bit perplexed by noticing that at office hours that everybody thought that because I had some old code in various branches that where I toggle a star using a separate star table, everybody somehow thought that the star table had to exist. And even though in the homework instructions, I never mentioned a star table, and I wanted you to do it with one table only. I mean, you're not gonna lose points, but it's just unnecessary complication due to a sort of refusal to try to think from scratch rather than follow an example that you think you might be able to adapt, okay? And if I can, I'd like to give you some encouragement to sort of break out of this mold and look at things and don't do stuff just because it's there as an example in some other context, but actually do stuff because you think that it's needed in that particular situation, okay? Another example that drives me up the wall, I mean, again, not in terms of grades, but, in terms of aesthetics, is the fact that, you have a table about products, and I think, half of the examples I saw are called post name. It's not a post, it's a product. You might want to rename it, you know? I mean, I guess you have examples, but not because you have the examples that, you know, cite one name and you have to go on. I mean, I know that there's a temptation of, you know, if it ain't broken, don't fix it, right? And that's a good general principle that I apply myself to many things like appliances, right? But in this case, you actually need to be able to know how it's made inside, you know. So it's like, you know, you really have to take apart the washing machine essentially. Even if it works in a particular example, you may want to take it apart and reassemble it in another way to make it what you really want it to do. Okay, so I was a little bit, you know. I mean, I know that we are all busy, and so I think that this is 90% of the reason. So everybody looks for the shortcut that gets the job done in the fastest. But I'm simply telling you that if you do that over and over, you are sort of missing something in the class, right? You are missing some of the beauty of actually putting the thing together, looking at an example on your side, but putting it together from zero, which I think is a better learning experience. So now I shut up, okay? But in the meantime, I gave you time to check in. Is there any question that I can take now before I start? Yeah.
Can you please give us one more day of extension?
Yes.
Okay.
I don't know. I will think at it. Usually I give you extensions when I made mistakes, not when you make mistakes. So I made a mistake by not recording the lecture, and so I give an extension. But you know, because otherwise it gets always one more. I might give it, but I don't know. I need to think a moment. Okay, I'll communicate it after the class. You will see me lecturing sitting down, unfortunately. Yeah. I also think, by the way, it will be better because I always hate wearing glasses, the eye-hand coordination of standing up and sitting here. Actually, I think it will be somewhat better. So I hope this will not be too bad. Other questions? Okay, so what I want to do, it seems a lot of people missed what I did on cross country would be the word that comes to my mind. No, cross-site attacks. And so I want to give you quickly the example once more, so it's recorded, and then I want to continue moving on with material on databases. I didn't want to do it last time because it requires a tiny bit of setup talking about cross-site attacks. So So let me do it like this. Sorry, wrong window. Yeah, there is always this gremlin from the top, right? Okay. So I built two sites. They're the same ones as previously, okay? And please don't play with them because, they're not protected. They're here just to make this experiment. In fact, let me see if somebody played with it. No, nobody played with it yet. So this is the all.post method that is non-secure, okay? I can have a title and content, okay? Now, this form in code looks like this. If there was a way to sort of kill that thingy, I would, right? So this is the form. It's a form that I built by hand. It's not built by Web2Py. The other advantage of sitting is that I don't wander around, and so the audio is better for those people following on Zoom, by the way. So the form is this one. It submits to the same page where it came from, okay? And it contains, in the end, two input fields. One input field with a certain name called post title, and another text area, so not quite an input field, but text area also with a name of post content. And then there is another, input field, which is of class submit. So this is not somewhere you can type, but it's a place that, when you click on it, the form is submitted, okay? And I told you that this form is insecure because of the following reason, that if somebody else builds a form that submits via post to the URL where this form came from, okay, the problem is that the other site is going to submit to me with a correct cookie. essentially, imagine that the other site where the scam appears is called, I don't know, my horoscope, right? You go there to find your horoscope. Whereas you are logged in another site that is, I don't know, like whatever, like Expedia, okay? So in Expedia, you're doing important stuff and you're logged in, but then you go to read your horoscope. If on the site your horoscope, somebody builds a form that submits to Expedia, the browser helpfully will include the cookie for Expedia, okay? Because the browser includes the cookie with a request to each site. So if the browser does a request, get or post to a site, it includes the cookies for that site. So even though you clicked on a button from My Horoscope, the request will arrive to Expedia, including the Expedia cookie. And so Expedia will think, hey, this person is logged in. It just made a post. Let me do something on their behalf, like buying a ticket for this Joe Smith that I don't know to go to Acapulco, okay, and enjoy life there. Okay, so you see, the problem is this, that the web has a sort of funny security model. You would imagine that you need to be logged in a tab in order to be able to send stuff to the site where that tab originates, right? But this is not true. The security model of the web is different. Whenever you do a request to site X, the cookies for X are included with the request, okay? And so here I want to give you an example, and I built these two sites. There is lookatteachingapps.com, and I am in start default at 1, or I am simply at the index, right? But so this is lookatteachingapps.com. I really have to deploy this code in the cloud. You cannot see what I'm doing if you just serve from localhost from 2 different ports, because in that case the cookie is shared, and the example doesn't quite work as well. So I really have to have 2 different URLs to exemplify what is going on. So this is lookatteaching, and it can accept this particular form that, as we have seen, has no particular security method in it, okay? So then I built also this other site that I called lookatteachingapps.com, in which I ask you a question: how much do you like bananas, right? And there are 2 buttons to reply. And this can be, rather, would you like to see your horoscope for the day? Or, I'm running a survey on, I don't know, how many somersaults can you do underwater, whatever, right? It doesn't really matter. But let's look at how I produced this form. In order to produce that form, I took the form add 1, I cut and pasted it, and remember, an attacker has access to your form, right? Because the attacker could have gone to your site, it could have gone, say, to Expedia to precisely look at how the form for buying a new ticket works, right? Forms are not secret per se, I mean, the general shape of a form. So I cut and pasted this, and I put it into something that I called also, I called attacker.html. It has the same code, except that instead of submitting to the same site where it came from, which would be pretty useless as an attack, I tell it explicitly to submit to lookatteaching, so to the other site. I'm building the attack here. And I am doing the following. I have the post title and content that have a value, like you need to eat more bananas, and for the very best bananas, visit bananas.com, which, as far as I know, sells guitars, right? So, but yeah. So no relation to the class. But just as an example, but I made these 2 rows here. They have a style of display none. This means that the rows are hidden. Okay, so the user does not see these 2 rows. So the user only sees how much do you like to see bananas. This information on the top, and then I just included the 2 submit buttons that would cause the form to be submitted, that are called, one is a lot and the other is not so much. I mean, this is a naive attack. I guess I'm not really trying to teach you how to make the best attacks. I'm just trying to teach you that these attacks exist and how to protect the site, right? So that's more of the spirit, I guess. But if you are here and I say that I like bananas a lot, okay, what happens? That I click here, and you know, so this is not a perfect attack because I land on Expedia, right? And then on Expedia, I mean, on my other site. And I would wonder, you know, hey, what the hell happened, right? So you may want to conceal the attack a little bit more. But you see that the title, you need to eat more bananas, and the content are here, okay? So my replying to that supposed question on how much I like bananas caused an insertion of a record in another site. This is Luca teaching, okay? So this is an example of the attack. And we have to contend with this type of attack all over the place when designing the websites. And so there are two ways we defend against these attacks. Yeah?
So the responsibility of preventing these attacks falls on the developer.
Yes.
So if you're a user of the website, you basically have to trust them that whatever that they prevented that.
Yes. Yeah, I mean, what do you want to do as a user, right? As a user, you may not have any clue what is happening behind the scenes, right? I mean, I don't think that the average user is able to inspect forms for presence of cryptographic cookies or cryptographic tokens. So what you do is this. Rather than building the form yourself, you use one of the forms that are built by Web2Py. So this form is built by doing this. Oh, definitely better sitting down when I code. SQL Form Factory, right? SQL Form Factory or SQL Form directly. Basically, any form that is generated by Web2Py rather than you hand-waving it contains a security feature, which is oops, sorry. Yeah, it's me, you know, making confusion between, there are too many different browsers. I'm using Chrome today, just for the fun of it. So let's see whether Chrome is as good as Safari and I can zoom out. No, you see, every browser is better in some way. Okay. Oh, goodness. Okay. Do you ever want to like strangle? Go away. Okay, fine. So you see that there is a funny div with the display style none. And inside this, it contains something called form key, an input with name form key. Okay. Now, an input of name form key is not like a magic sauce secret. It's simply an input that will be sent to the server with a field name called form key. Okay. And it has a value which is a random string. And what is happening behind the scenes, which I'm not sure if I can show you, but on the server, in the session, the server is writing essentially these secret strings for every form that has been unreplied so far. This can be, unfortunately, a lot of forms. Because if I am Expedia, and if you are anything like me, you start to go in Expedia and you open 5 tabs because you know Expedia is not so smart and you want to search for your itinerary in 5 different ways, you know. You want to search with only one hop, with only airlines that begin with Q, with only airlines that fly upside down, you know, whatever you want, you know, to try to see whether they give you get a better price one way or the other. And so if I give you 5 of these search forms, Expedia will have extant, you know, 5 of these keys. And so associated with your session, there is in general a long series of these keys, each one of them with a timeout timestamp. And you know, they usually expire after 24 hours or 1 hour or whatever it is. I haven't checked, I admit, in default in Web2Py what the default expiration is. You don't want to keep them around forever because they would balloon without any limit, right? And in fact, somebody please remind me, at some point I have to talk about session management. The session for each user can be potentially large, as you begin to imagine now, because it contains not only the information about their login, but also all these secret information about the keys of the forms. And so, you know, having this large amount of information for every user, even though their last login may have been 6 months ago, may not be reasonable. And so we need at some point to be able to clean up this information. If somebody can queue these, maybe one of the TAs can cue these for me to talk about at some point in class before the end of the class, strategies for cleaning up the session, that might be useful, you know, because it's important when you actually deploy a site. But so essentially there is this secret key, and the thing works in this way. I give a form with the secret key, and this form, because it is processed by Web2Py directly, so because it is processed here by this process command, Web2Py, when it gets back the form, says, hey, does it have a valid key, a valid form key, right? It has in the session a list of form keys, and so it has to check, is there a form key in my session that matches the one that was sent, okay? And if it's not there, the form will be rejected. And in fact, we can make a try. Let me see if this weird way functions, okay? I say, like, I like apples, even if they have caterpillars. You don't know this about me, but I'm a maniac about macro photography. So I was spending some time over the weekend photographing caterpillars. So, and now I take this thing here, and let's see if I can change it, like blah, 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 Italian for yak, 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 or for, you know, meaningless speech. So now I sabotaged the form key. The point is this, right, that if you want to invent your own form to fool my security, you cannot guess the form key, because that's generated dynamically. You know, every time one requests a form key is generated and is given to the user and is stored in the session. But so you cannot predict what form keys are in somebody's session. So my guess of blah, blah, blah here is as good as anyone, right? I mean, it's just a random string. So what happens if I submit this form? So I'm not exactly sure what will happen, you know, whether my blah, blah, blah will be submitted as form key, but let's try to find it out. Okay, you see, it was sent and it came right back to me. And if I look at the network tab, I can actually look at the post. Oh, this is very nice for once, right? Because I can look at the post, and we can go look, request headers, yada, yada, form data. You know, this is a famous form data that gets sent, no? That you can examine actually in the network tab. It contains a post title of I like apples, a post content, even if they have caterpillars. The form key is blah, 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 and the form name is not able to create. This form name is because Web2Py tries to be smart and assigns a name to each form to kind of know what to do once they come back, you know? It's not, this is kind of deep information. You may not need to know it for the class, but you may want to dive into it if you want to do fun stuff with forms, okay? So let's look at the reply. The reply of these was, no, I think I want to look at the headers of the reply. So the reply is not a go away, which might have been actually. A reply is simply, I think this person messed up and I'm going to give them back a clean form. So it's a 200 OK in which I'm giving them back a clean form, but no insertion happened in the database. Okay, and I can navigate back to the index page that show you that there is nothing that happened. I just wait a moment, because once I navigate back to the home page, you know, we cannot see this request in detail anymore. Is there any question on this request? Yeah.
So that form key,
yes,
seems to like you send it to the client.
Yes.
The client can just look at it.
Yes.
Isn't that the client can just attacker just can
Yes, no, these are really good questions. He's saying, you know, hey, if the browser has a form key, can't an attacker use it? I mean, I can use it. As a user, I am free to shoot myself in the foot as much as I want, right? I can take any page that the server gives me, tamper with it, and send it back. You can do whatever you want because it's you doing it, no? So if you want to be stupid, you can. You have the official authorization. If you want to buy an expensive ticket for Joe, you can, okay? But the point is that the tab that you get on horoscope.com cannot access the content of the tab on Expedia, okay? So you as a user clicking on inspect content, you can inspect stuff with your eyes. But the tab of another site cannot access, and this is, you know, one of the fundamental security things about forms, about browsers, you know? a web page running in a tab has no access whatsoever to the data of other pages running in other tabs. And if this was not true, essentially everything would break loose on the web, right? Because you would have, I don't know, Facebook siphoning off all your emails from Gmail and vice versa. I mean, it would be a cowboy land, I guess, in some way. Yeah.
So it's all the browsers pretty much enforce like sandboxing, right? So like one tab only has its own tab and it doesn't know anything about any other tabs.
Yes, and there are two different ways of sandboxing, actually. The way that was pioneered by Google Chrome is the one in which each tab is its own process, separate process. This means that every tab has its own memory space. This means that Chrome uses a lot of memory, but this also means that the insulation is very good, and if a tab crashes, only that tab crashes. At the time Chrome came up with these, it was a great novelty. I think you can still look, if you search on the Google Doodles that came out to explain users about this new isolation feature. It was a very nice feature, actually, and it was very innovative. Browsers have since copied it to some extent. It used to be that if a tab crashed, your whole browser crashed. Now, for example, with Safari and I believe also Firefox, there is some insulation of the kind, so that if you crash a tab, not all the other tabs crash, but there is some sharing. And I do not know very well what is the execution model of the other browsers, actually. I think it has changed through time, okay? Yeah, but it's a very good question. Other questions on these? Okay, so good. So let me go on. 1 second. Okay, I just wanted to maybe close these and I'm going on a little bit with what I wanted to do. I'm sorry, these lectures, I have some slides that I want to continue to show, and perhaps the slides are a little bit boring, but I promise that I try to go through them somewhat quickly and efficiently, and then we can play with examples, okay? So, I already told you that about insertion last time. I just want to make a brief summary. There are two common cases. One is that you want to insert a row and you are sure that you want to insert it. But a very common case is the one in which, hey, if I don't have a user called Ugo at csc.edu, then I want to insert it. But if it's already there, I just want to bring up to date the values associated with that particular user, okay? And so what you can do is an update or insert that has essentially as first parameter a query, okay? And you could even make your query more complicated. Let me do it, in fact, just to show you how queries are made. So, for example, this will be the email is Ugo, and I don't know what is a good other cause, and registered is equal to true, okay? Note that if you do a query on a Boolean field, you really need to ask that the value is equal to true. Okay, it's not enough for you to simply say registered. And notice also that you don't use and or operators as you do for normal clauses. You need to have this ampersand or vertical pipe to do conjunction and disjunction of conditions in queries. This is because behind the scenes, sorry, let me just make this a little bit better, because I mean, this would need to be done this way to really make full sense, okay? So let me just do it, okay? So you may wonder, if you're new to Python, how this thing can possibly work, because some of you that know the language know already that ampersand has some other use in the language, which I actually forgot. What is it? I think it's intersection for sets, and it may be also something else for bit fields. I really forgot about it, okay? Does anybody know what is a single ampersand in Python? at any rate, Python has this feature in which you can redefine operators, okay? And so you can associate meaning to them. And so what Massimo Di Piero and a certain Giovanni, whose last name I forgot, who are the two main authors of this PyDAL, the Python database abstraction layer, they essentially overloaded the ampersand operator to make sure that if you had the two queries, this would represent the queries that is the conjunction of the two separate queries. It's just beautiful syntax, and it's a trick that is fairly often done in advanced Python coding. Okay, you can redefine the meaning of the operators. Okay, if you think at it, the plus is also redefined in Python because the normal plus is a numerical operator, but if it's applied to lists, the plus applied to a list is list concatenation, and applied to string is string concatenation. And so what Python does is it gives you a general mechanism so that you can define data types that can override the operators for how they are applied to them. Okay, and Massimo and Giovanni exploited it well while they created that database abstraction layer. Another thing that I wanted to tell you is that this DAL, database abstraction layer, which I find it incredibly pleasant to use, is available not only Web2Py, but Giovanni extracted it from Web2Py and made it available as a separate project. So if you now Google for database abstraction layer, DAL, or etc., there is its own GitHub repo, and I've used it with success in projects that have nothing to do with the web, actually. I just wanted to have a database backend where I could easily move from MongoDB to MySQL without any trouble, writing the same queries. Maybe I should talk later on in the class about what are the trade-offs, but just to tell you that this database abstraction layer is actually usable in any context. So there is an update statement. The update statement has this syntax in SQL that we are not going to use very much. For us, the most common way to do an update is this. We get a row representing the record. The row must include the ID of the row, right? Because that's used to know which row to write back. And what we can do is that we can change fields, and then we can call update record to write the information back to the database. This is one of the various formats in which you can update the database. And for other formats, you can look up in the book. There are many very useful shortcuts, but I don't want to give you all the shortcuts because it would be rather boring. Delete is done in this way. I just give you the example in our syntax. So you essentially say DB, and you pass to the DB a query, and then you say delete. And this will not delete one record only. It will delete anything that actually matches the query. Boom, gone. Not trash can. Okay, not trash is once it's gone, it's gone. Database tricks. So these are database tricks that I use quite a bit, and they're super useful. One is to say first. So very often you do a query, but you now know that there is actually either no element or at most one that satisfies the query. This is super common, right? Maybe I know that people have a unique email in my system, and I just want to fish out this user that has look@ucc.edu as email, and I know that there's going to be one, because I've paid attention when I created them to use an update or insert rather than an insert, right? So what do you do if you just need the one? Okay, you do this. You say DB, you put the query, then you say select, and then you say first. So this returns either none or the single element. Okay, so this is equivalent to say row is equal to none for row in DB query break. No, so the problem is that DB this object. Oh, okay, fine. I always forget that I cannot highlight on the screen, but this object that goes from DB to the end of the select, if you this expression returns an iterator. And so you cannot simply say, you cannot directly use it. You need to get to the first element of it. And it's truly boring if you know that there is at most one element, And so that's why the shorthand above comes very handy. Okay? Another database trick. Sometimes you want to get the elements as a list. not as an iterator. Now you may wonder why, but for example, suppose I want to get all the students who jump higher than 2 meters. That's pretty remarkable, right? And I want to get the list of those students and, you know, write it somewhere else or dump it to something like in JSON format, to do whatever, right? But I don't want to iterate on the results. But in this case, I just want a frozen list, no? How do I do that? So the way is to say select and as list. This has 2 consequences. First of all, you are not given an iterator anymore. You are actually given a list. This also implies if the database changes, the iterator is unaffected. I mean, the list is unaffected. The list at that point does not have anything to do with the database anymore. It's simply a pure plain vanilla list. The other effect is that being a plain vanilla list, and in order to facilitate operations, it's not a list of database records that you access with the dot notation, but it's actually a plain old dictionary. So it's a list of dictionaries. So you can say, for row in my list, print row name, you know, using the dictionary notation for fishing out elements. And this you know, is useful sometimes. There is plenty more of these interesting tricks to do in a database. But I really don't want to go over them all. You know, please skim the chapter on the database abstraction layer, if not immediately, at least when you need to do some fun operation on the database, you may want to look at it. Sorry, hiccups. Normal forms. So the people who study databases tell you that you cannot just junk information around in any kind of format, but you have to essentially respect some normal forms. So essentially, let me put it in a way. You can read the slide better at your ease, but what they want to do is essentially is ensuring one property, that when something changes in the real world, so in the data that the database is supposed to capture, the change that you need to do in the database is simple, isolated, and hopefully to one place only. Okay? So let me give you with examples, you know, what they were about. So the first normal form says every field contains atomic data, a phone number, not a list of phone numbers. Okay? So for example, if you're building a contact book, for every user, you don't have a list of phone numbers. You would have to have a separate phone field that is associated with each user says, I'm the number 1234 and this is mobile. I'm the number 5678 and this is home, okay? Now, this first normal form, in practice, people cheat every time and use other forms, okay? So why do they do that? You know, I myself, okay, let me jump a bit ahead and write a database in 2 different forms for keeping a contact list. Okay, so let me do. I want to do this class more interactive than just the slides. So let me do these. Git checkout master. Okay, git checkout branch DB examples. Okay. 2019. Well, okay, so for example, now I can go in one of my editors. Everything has disappeared. Okay, and I can start writing some code. So let me write manual violates first normal form. Okay, so I say DB define table, and I call it like addresses. Okay, and then let's define a table for an address book. There is a field name. Suppose I don't worry that, you know, my SQL, SQLite will start to scream, name is taken, name is taken. I don't care. Okay, field like last name. So this would be first name and last name. I mean, there is more information, okay? But let me point out to one solution. Field phones, okay? And maybe it's of type text, so I can junk in it a lot of information, okay? And then I can put other stuff, okay? And then I would write to the database. This is an example only, okay? I'm writing here as example, so this is not really something that is meant to execute. It's just me having like a sheet of paper in front of me. But like an example of insertion would be something like this. db dot addresses dot insert, okay? And so I want to say that the name is, sorry, the first name is Luca, okay? And the last name is, sorry, name is, yeah, I'm trying to quickly reconfigure my brain to, you know, avoid using the little finger, and it's an interesting experiment. Fonts is equal to, maybe I should introduce now a topic. How do you convert complicated information into a string? Maybe some of you know, okay? So you use JSON, okay? So you do the following. We will come back to this, okay? But IPython, as opposed to UPython, I guess. So here we are in a Python console, okay? And I can say things like, please move this up a bit, right? Okay, maybe you can see better. So I can say import JSON, which is a module. And so imagine that I have the following information for me, okay? I have, what would be my address, my phone numbers? It would be a list of pairs. Like fonts, my real fonts would be a list that contains a pair which says, for example, I don't know, 1, 2, 3, 4, and says mobile. Okay, so this is one phone, or maybe it would be a list of dictionaries. That would be a bit better. Like dict number is equal 1, 2, 3. Well, it would be better to be a string. And 1, 2, 3, 4. Okay, and what is equal to mobile. Okay, this would be a more typical representation. And then there is another dictionary that says that my number is 4567. Sorry, the number is 4567, and the what is I don't know, like home, something like this. Okay, so so here we have a list of 2 dictionaries. This is a, you know, a classical thing to do in Python. So if I say fonts, this will be printed out, right, as a list of dictionaries, okay? So this seems like a reasonable thing. And now you want, how do I write such a thing in a database or to a file? So essentially the question is, how do I take something like this and serialize it to a format that I can actually write somewhere and read back and reparse into a list of dictionaries? Okay, so this problem is like, how to say, this problem is specific to a list of dictionaries, but you can have a dictionary which some fields have as value a list. I mean, in general, in Python, as you may know, you can build a lot of stuff up of lists, dictionaries, and strings and numbers, right? If I give you those 4 types, you can build up a lot of information. But the question is, how do you easily and unpleasantly convert this into a string? And the solution is this, that you say S is my string, is equal to JSON dumps. Dumps is not the third person plural, singular, but is dump to a string. The S is for a string. The default, if I say dump, it dumps it to a file, okay? So this dumps to a string the fonts. Actually, it works well as a third singular as well. So if I do this, the string S contains this, and you tell me, hey, you know, but that's the same thing. Well, almost, but it's essentially a string. S is a string that contains this stuff. Okay, that's the content of the string S. Okay, now I can say, like P for fonts is equal to JSON, or I can say, what is the type of S? So you see, the type of S is a string, whereas the type of fonts is a list, right? Because it's a list of dictionaries. So you see, we actually have converted fonts to a string. If I want to convert it back, I can say P is equal to JSON loads of S. Okay, so this means load from a string, and now P will be this. You say, hey, it's the same. Well, it's not quite the same, actually, if you look at it carefully. It's not the same because of two things. First of all these keys have become Unicode. So before it was a normal N, and now is a Unicode N. And I think that if I want to tell you the difference, I will do it another time. Or I circulated actually among students of the School of Engineering in general a Python tutorial. You may have it also in the class material. If you want to know about Unicode, look in that Python tutorial for Python 3.7, okay? I'm getting N telephone calls from the same number. And so, you know, it will be interesting because the problem is how to do, yeah.
Why did it switch the ordering? Mobile was first originally.
Yes,
now mobile second.
Right, exactly. And it's because in dictionaries, there is no given order in which keys are. In Python, there is a data structure called ordered dictionary in which the keys are preserved, the order of the keys is preserved. But in general, the order of the keys is not necessarily preserved. And it's implementation dependent, right? And so it may depend on the order of insertion, and it may depend on other stuff, you know? So it's not one of these things that is preserved, okay? So that's the reason. Now, there is a little bit of a difference in this sense. Suppose I create a crazy structure, crazy, CSE is for crazy, that is a dictionary, right? And it says, at 1, it associates 2. And to 4, it associates 8. It's my poor man's way of doing doubling, right? So CSE is a dictionary and it's fine. And so I can say the string T is equal to JSON dumps of CSE. Okay, the string T is fine. But then I can say JSON loads from T. Okay, boom. Now this is different from where I started. You see that the key is a string. So one limitation of JSON is that it thinks that the keys of dictionaries must be strings. In Python, you don't have this restriction. In Python, anything that you can compute a hash function of, including obviously integers, is good enough to be a key of a dictionary. But in JSON, the keys of dictionaries need to be strings. So if you need to serialize stuff, you must be sure that your dictionaries have strings as keys. Otherwise, otherwise funny stuff happens, basically. Okay? So this is a way to convert most data structures to a list, to a string. And it's super important, and for us will be incredibly useful to use JSON in all the second part of the class. Let me now use it for the purpose here. I can say JSON dumps of Luca phones, right? Luca phone list, something like this, okay? And this will do an insertion in the database, okay? And so even if I have 10 phone number associated with Luca de Alfaro, you know, this boom will will throw them all into the same database field. What is the benefit of throwing them into the same database field? The benefit is that when you click on Luca de Alfaro in your contact list and you want to view the phone numbers, you don't need to do extra database access. If you read the record for me, you have read already all my phone numbers. So you can present them very easily to me on a list, with very low latency, okay? What is the problem of doing it? The problem of doing it, why it might be a bad idea and why actually the first normal form would advise you not to do it, is the following. Suppose, as in my case, that you got 5 phone calls from the same phone number and you would really like to know who that phone number is, okay? The problem is that in a database, you cannot easily do a search. Hey, tell me whether this phone number 2345 appears somewhere in your contact list as one of the pieces that you jumbled up in the middle of this JSON information. I mean, you can do such a query, but it's extremely inefficient. The only way for you to do that query is basically to read every row in the database. There are some facilitations, but they really work really, really poorly. For example, I can say, hey, please give me everybody in which if you do the grep, if you do the character search in this fonts field, you find this string of contiguous characters. There is a query like that in MySQL. It's called the likes query. But the likes query still has to read all the records from the disk. Sorry if I go in jumps, but I don't know how to teach better, okay? What is the difference between reading all records of the database and doing a likes query? It's essentially minor. Suppose that the MSI tutor is the database and I'm the web server. If I do a likes query, this means I tell him to please read all the rows of the database, but he doesn't actually have to send them all to me. If I read all the rows in Python, he has to not only read all the rows, but also ship them to me over an internet connection, which is bound to be slower, right? But this does not avoid the fact that you need to read the whole database to know who is this person that is trying to call me, okay? So instead, if you want to have in first normal form, you would have to do as follows. Actually, this is much better than using the slides, doing the lecture by example. So let's build the table. I would still build some of this table, right? So I would still build this, but I wouldn't put the fonts in, right? I would simply say first and last name. And then I would do a table that says define table. And I would call the table phone, right? And the phone would remember things like field, type, like phone type, I guess. Whether it's mobile or whatever, right? You need to remember this for a phone. And then you can add a field that says like the number, right? And it's a string probably because you want to do like +1 or +11 or plus whatever, no? And then you want to, and now the problem is this. This can contain a person like Luca. This can contain a phone, but how do I say which phone belongs to which person? I have to say essentially that this phone belongs to this person. How do I do that? I add a field here that says field, and this I can have various solutions. Let me give you one, okay? Like I can say like user, like person, I don't know, or like address, I guess. And the type is a reference address. Okay, so this will contain the ID of the addresses row. Let me show you with an example what this means. Let me go back to the slides in which I have a similar example for something else. 1 second. So you see, this is an example of a database in which I have students and I have majors, and I wanted to know for each student which one is the student's major. It's similar to the problem I had before. In the problem I had before, I wanted to know for each phone number to which person it belongs. So what you do is that you include a pointer. In each student, you include the ID of the major in which the student is. Okay? And they can create these by creating a student table, a major table, and so then saying major ID is a reference to the major. Okay? And so in the same way, I can do it in my code by calling it actually address ID, which is a reference to an address. Let me call this address, which is a bit more beautiful, okay? So this is a way to do it for my address problem. This does not limit the number of phones that I can have associated with me, right? And every phone will be stored independently. So now, let me write a few queries that you may want to write on this table, okay? Like, what are Luca's phones? Imagine that there is only one Luca in your database, okay? Just to be faster. And you can say, for row in DB, and now we have to write the DB, now then select, okay? So here inside we have to write the query. What will be the query? It will be something like this. It will be the conjunction of two parts. One is DB address first name. Okay, this has to be Luca. So this tells it, hey, I want to know about Luca. Okay, but this is not enough, because if I say only this, if that was my entire query, I would be fishing out of the database only the fields that are related to my address, so my first and last name, right? You would get all the information about all the Lucas in the database, which is not what you want. You want also to know all my phone numbers, okay? So what you want to say is that there is another query here. I split the line just to be clearer, okay? And the other query, sorry, says something like this. DB phone address ID is equal to DB address ID. Okay, so essentially, this is the query, part of the query that says specifies I want to know about Luca, and this part of the query says, oh, and I want to get also all the phones that have as address ID the address ID of the other row, right? So this essentially establishes the connection between these two tables. You might expect that the connection was built automatically for you, but it's not. Okay, you need to specify that you're selecting the fields that have this address ID pointing to the ID of that other table. Yes.
So is the single ampersand equivalent to just A and D? Just and?
No, it has the same meaning in your brain, but when you write a Web2Py query, you need to use a single ampersand and not the word and. The word and will give you some kind of error, some kind of syntax error or type error or whatever. Yeah.
All right, thank you.
Okay. Is this clear so far? Now, the problem is this. Yes.
So when you do this inquiry, it's gonna go look for at the address table and also the phone table. Are they gonna combine the two?
Yes, yes. This is what I want to come now. It's a very good question. Thank you. But so let me write a moment the equivalent query here. Okay, for row in DB. DB address, let me call it address so it's uniform, okay? I don't want to have like multiple differences for no good reason. DB address, like first name is equal to Luca, okay? Select. Okay, so here you have a field. I mean, I don't want to do print because I theoretically couldn't, but let me do print just to be stupid, just to show you what it is that you get, okay? You can say print row dot first name, no? You can do it. And you can also do print row, print JSON loads, okay, of row dot fonts, no? These are two statements that make sense, except that you're not supposed to use print but log. But if you forget about that a moment, this makes sense, okay? So now let's come to his question. You know, if you now ask to fish out information from two tables, how do you do that? And you do it using the following, okay? Now I can find print row, and his question is now row to which table it belongs is his question, essentially, even though he, and so the fact is that you need to specify it this time, because whenever your query involves more than one table, you need to specify. So you would need to say row.address.firstname, and then you would have to say print row.address.lastName. No, sorry, row.phone.number. Okay. Not only, but suppose I have two phone numbers, I don't know, an office and a mobile phone, right? Then you would print Luca 1234, and then you would print Luca 5678, right? So this iterates not on every row, but on every combination of the rows that satisfies the conditions. You are essentially blowing up the correspondence, expanding it. Okay. So in a sense, you can complain, you know, hey, but I'm extracting the first name to match. Okay, fine. Then you can do the like this. For row in DB, sorry, let me just go cut and paste so it's a bit faster, okay? Let me give you another example of stuff you can do, okay? Dot select, okay? So this will select all the rows for me, okay? And then I can say something like print. Sorry, I'm writing in a stupid way as if I'm writing, you know, the output in ASCII, but it's just to give you an example without all the complexity of building a web page around it. But I can say print for, and then I say row dot first name. Okay, I have these numbers. Okay, and then I say for another row in DB phone address ID is equal to row.id select. So you see the second query now, I'm doing it explicitly. I want to fish out all the rows in the phone that point to the ID that is corresponding to the user I fished out in the outer loop. Okay, and I can say, for example, print. Okay, and then I can print, for example, arrow.font type. Then I can print a colon, and then I can print arrow.number. Something like this. Okay, and this will print something like for Luca, I have these numbers, and then I would write something like mobile 1234 and Office 5678. Okay, or 56. Yeah, I mean whatever, right? But so this is what you would get as output of this. So you have two ways. This does the zip. This does, you know, the. I mean, it's like how it is called, like oh boy, like a zipper. No, a zipper. Yeah, it essentially, you know, connects all the records that belong together with the query of the two tables, right? And this instead does. This does more queries because it does a query for every person, and then for every person it does one query for every phone number of that person. Okay, so now you may wonder, you know, which one of these two is better, and the answer is it depends. Okay, for phone numbers maybe this implementation would be an epsilon faster because, you know, what the general rule is this: the database guys are really good at optimizing stuff. No, that's what they spend their lives on. So they're really good at implementing these queries in order to run really, really very fast. So, so if you do a single query and you let the job onto them, generally this will work a little bit better. The one constraint is if too much information needs to be sent over the wire. Imagine that here you are not only sending my first name, okay, but you are sending, for example, the entire collection of papers that I've ever written, or maybe, you know, so, I mean, something big, like no, rather than the stupid example of the papers. Imagine that you have a photograph of my face. Okay, the photograph of my face may be 1 megabyte. Then in that case, using the above solution would be a bad idea, because if I have 8 phone numbers, you would be reading 8, you would be not, it's not really that the database would be reading 8 times my image. The database would be smart enough to read it only once from the disk. But then it would need to send me over the wire, over the you know, the internet connection between the database and the web browser, and the web server. It would need to send me this 1 megabyte image 10 times over, right? And this is silly. This is too expensive. So if you need to have too much information that is repeated, then this latter solution is better because it reads only once the record for a user. And because the record of a user in that case would be so much larger than the information about the various phone numbers, is much more convenient to split it into queries. This is a sort of way of telling you, you know, there is no right way. You need to actually think at how you are storing the information how you will be using it and how you will be retrieving it in order to decide on the best implementation of a database. And there is generally no escape from that. The general advice I give to people is initially do something simple and complicate it only if needed. Because what happens a lot of times is that initially you don't really have a very good idea of how you will be using the information in the typical case, okay? But so what I did here, the formal name of this is this, that this thing here is called a foreign key. This is a strange name, which reminds me of spy novels somehow. I probably would have called it in a different way if it were me, if it was me giving it a name, okay? But essentially, the idea is this. You know that address.id is a key to this table address because it defines in a unique way a row. A foreign key is simply a key to a table that appears in another table, in a foreign table, if you like, okay? So it's what we poor computer scientists would have called a pointer, I guess. Okay, well, it's not quite, you know, the notation is a little bit different because a foreign key doesn't need to be simply the ID. If you wanted, and in fact, in CrowdGrader, I have implemented stuff by saying, I could actually show you some of the real tables of CrowdGrader, I guess, except it's all recorded, so I won't. But another way to do stuff is this, like inventing CrowdGrader. Okay, let me give you this as an example. DB define table, and I define a table called the submission, which is a homework submission, okay? And now I have to tell you to whom the submission belongs, right? Let's see how to solve this problem. I can say, for example, field, let me call the field student in every case, okay? One idea is to say field student reference auth.user, which is the name of the table where the user information is stored. This is way one. Okay. Student, I mean, this is invalid, okay? I'm just giving you multiple alternatives. I'm not giving you a valid definition of a table. I just want to show you various ways of defining the same thing. Another thing that I can do is instead say something like, sorry, student. I can say something like this. I simply say it's a student and say the default value is auth.user.email. Actually is get email. Okay, and before I say def get email. Okay, and I say return auth user, return like none if auth user is none, else auth user email. This is just to show you that in reality I have a bit of flexibility. When I refer to another table, I can use more than one way. A common way is to use the table ID, row ID to which I refer, which would be way one, okay? Via ID of table of user, okay? But I also have other ways. Way two, via email, okay? If you are designing a real product, each way has its own advantages. Using IDs is slightly faster. Using emails is slightly more general. Because if I use email, I can do things that I cannot do if I use IDs. Let me give you an example. Let me assume, in fact, in CrowdGrader is true, that let me assume that you can work in groups. So Luca is in the same group as John and Ada, okay? And so I know that John at ucsc.edu and Ada at ucsc.edu are my friends, are my collaborators, okay? If I use emails to refer to people, there is this beautiful property that I can refer to them even though they have not logged in yet. If instead I use IDs of the auth user table, until people actually log in, there is no record for them in the database, and so there is nothing to refer to. Okay, so sometimes I've personally found actually that using emails rather than user IDs to refer to people is a better strategy. It gives you two advantages. You can refer to people who haven't logged in yet, and it's also more readable for debugging. Referring to people who have not logged in yet is incredibly useful. For example, suppose I give you a button that says, I don't know, please send an invitation to your friend and you will get a $10 discount, whatever, right? Then you will send an invitation to Beatrice at ucsc.edu, no? You will cause an invitation to be sent to her, and I give you the $10 discount. And now I want to somehow remember that you invited Beatrice. Beatrice will not have logged in at that point, most likely, right? Because, I mean, that's why you're inviting her. And so it's very useful for me to have a way inside of the tool to homogeneously refer to people, even though those people may not be members yet. Okay? That is something I found. So I just pass it on as a suggestion. Now, let me take questions and then go back to my slides that show you some other aspects of how to do these foreign key relations. Questions up to this point? Yes.
The reference that has to be defined for that.
No, the reference is beautiful. You can also swap the order. Another excellent question. Thank you very much. In fact, let me go to a place where I can make an example. Yeah. So you can have circular references, right? You could move these on top and it would still be fine. This would be fine as well. The database would be smart enough to know what's going on. The truth is that I could also write here, and I just write it to you as an example, but I tell you that it's not a super smart idea. You can also say address ID, okay? And here you can say db address ID. I think that this is a shorthand for the same thing, okay? But I wouldn't use this second syntax because this second syntax assumes that db.address is already declared, and so that this declaration came before. So this notation is not flexible, whereas the one I gave you with the reference address, that is flexible. Okay, so that's why I use it. So that if I reorder the code in order to, you know, beautify my code, I don't get into a trap.
When a record is entered, address underscore automatically.
Oh, yes. How do I add a record? Another excellent question. Thank you so much. How do I add the records? Okay, so let me add how would you add a record for me? Then tell me which problem you want me to solve. Because, for example, you may already have me in the database, or you may not have me in the database. Which one of the two cases you want me to make? You don't have me at all. Okay, so you don't have somebody at all, and you just gave me like a create a new entry for Ugo. I'm sorry, but Ugo is a short name. It would be with an H in front in English, right? But it doesn't matter. For Ugo with like 1, 2, 3, 4 as mobile, okay? So here you do db. So you do the following. You say user ID is equal to db insert, and I say, sorry, not db insert, I'm wrong, db address insert, and I say first name is equal to Ugo, okay? And last name is equal to Del Faro, okay? Because that's my default last name, okay? So you can, so these inserts in one of the tables, not in the other table. In Web2Py, you have to insert in one table at a time, okay? But notice the thing, so far you never saw these. You saw me using db address inserter to insert something, but you never saw me using the result. Actually, when you insert something, it returns to you the row ID of the new row that has been created. I told you that this is a long integer and it's updated via auto increment, right? So now that I have this ID, I can say db phone insert, and I can say I can say address ID is equal to UID, and number is equal to I'm sorry, but 1, 2, 3, 4. Okay, this is how I can do it. Okay, and I can also give you the example. Add the number for Luca. I don't know, home as 1357. Okay, so how would you do that? Imagine that there is only one Luca. Okay, or imagine that there is only one user first and last name combination. Okay, so then you can do like this. Row is equal to db address dot first name is equal to Luca. So this can fish out everybody who is called Luca. Okay. Now assume that I also want to specify the last name, and db address last name. You know, I don't know if these parentheses are needed or not, frankly. So in case of that, I put them. Now, if I do this select, you remember, if I do this, I get an iterator, right? So I get the list of results. So suppose I'm sure that there is only one, then I can do actually first, okay? With the shortcut I told you before. So this will give you my first row, okay? And then I can do the insert, because I can say db phone insert, and I can say address ID is equal to row.id, number is equal to 1357. Okay, maybe it would be kind of cleaner to say if row is not none. So if I exist already, else I need to do insert also of the address as above. Okay, so that's generally how the code is written. Okay, so there is a whole chapter in the Web2Py book that teaches you many of these queries and many of these methods, and you know, I will go over several of them, but at some point you need at least to browse it. You don't need to memorize it, obviously, but give it a look, give it a quick scan of the subjects so that you know what's in there. Okay, so that when you need it, you simply search it up and go to the right place where it's explained. I really recommend you do it. Okay, so that was another excellent question, how to do the insertion. Okay, the deletion is kind of easy. Like, let me assume delete all Maria info. Okay, just as an example, how would I delete all the information related to all the Maria? I mean, I may know multiple of them, but I want to just delete everything related to them. Okay, so you may think that you can do db address name is equal to Maria. Delete. Okay, does this work? Let me leave it here a moment and switch to the other slides, okay, and come back to these in 1 second. So there is one thing that you have to pay attention to when you define these foreign keys with this reference major in this case, or in my case it was reference address. There are 3 behaviors that you can choose. So the question is essentially, this is like a pointer, right? This foreign key. What happens if the thing you point to is deleted? What happens if a student belongs to a major and then the major is deleted? Or what happens, you know, if a phone number belongs to Maria and Maria is deleted? The fact is that you can choose. You can choose among 3 behaviors, and the database will enforce them automatically for you. One is on delete cascade. If you delete the thing that is pointed, you also delete the data. This makes a lot of sense for the phone number. If you delete Maria's record, you don't want to have like phone numbers associated with nobody. It doesn't make any sense, right? And so in that case, the on-delete cascade would be the proper behavior. And it's also the default, by the way. The default is cascade. In the case of a student belonging to a major, it's probably not a great idea to delete the student. The student is a real entity, right? The student may have paid the tuition for 3 years and may have enrolled in this major that is called the Fantastic Games. And now the Fantastic Games major is deleted because it's supposed to be replaced by the Serious Games major, right? And so the only problem for poor Joe is that they deleted the major Fantastic Games before they moved him to the Serious Games major. And so, boom, everything about Joe is deleted. Where he lives, what he has paid, the grades he has taken, everything is gone now. That's probably not a super great idea, right? So you have to be careful about which ones of these behaviors you want to enforce in the database. There are 3 behaviors. There is cascade, there is set null, which sets the major to null. In this case, Joe would have null major. And then, supposedly you would be running some other code on the database that sets the major properly for all the students who have switched and are in good standing or whatever you want to do it, right? There is also a default that says no action. I've never found that to be a useful choice. I think you can do that. Normally is not the right answer. Because normally, if you point to something and that something doesn't exist, it's not good to leave a dangling pointer that makes you believe that you can query for it, but then you come up empty. It's better to say then the major is none, okay? So but there are these 3 behaviors, and the thing to remember is that for some reason, the behavior that is the default is the dangerous one, is the behavior in which the deletion cascades, okay? When you create a real database in the cloud, and I will cover it later, but I'm sorry, but I continue to do all these parentheses. But the normal way you do if you create a database on Amazon or Google Cloud is that you configure your database, and then there is a beautiful, nice box somewhere in which you can say, please do a dump of my database daily and save it somewhere, okay? So, for example, the Code Creator database has daily backups and has monthly backups going back to the origins. So if I had some error in the code or if I had some mishap, I would always be able to restore at least a 1-day-old database. And everybody does this. I mean, it's essentially, you cannot have a database without having backups. And in fact, you should not only have backups, but you should worry about the fact that your backups should be geographically distributed again, just like the database, so that if a data center blows up, your data is not lost forever. Okay. So but that would be the only way you can recover from a mistake such as a delete cascade that you don't recover. Okay. I find it much better to teach by sitting. I have a way better ergonomics for me. Yeah, I won't go back. Yeah. Then next time I will try to teach by reclining. I have to get one of these love seats, like in the Roman frescoes where they eat grapes, and I will try that way. Just kidding. Yeah. Anyway, we can tell everybody attending remotely that I actually am on such a recliner, and they will be none the wiser, of course, right? So we could really do that. So this is the way to have one-to-many relations. Okay. Now there are also many-to-many relations. Don't worry, it works basically in the same way. So even if your brain is full already, as Calvin was saying, you may be able to absorb these, and then we are all happy. So a many-to-many relation is, for example, you have students and you have classes, but a student can enroll in many classes, okay? So how do you keep this relation between 2 different things? You need to introduce, in this case, a third table that represents the liaison between the 2 other tables, okay? And the third table will have a pointer to both students and classes, okay? So in practice, you would define this table as Let me define it actually, because I don't think I have a definition here. So let me quickly go. Students and classes. Okay, DB define table student. Okay, this is a student table. Let me just be very like field name, okay, because we don't want to waste time with these things, okay, but the student has a name, fine. DB define table classes, okay, classes, class, singular, right? And the class has also, I'm sorry, it has also a name, okay? So, I mean, fields don't need to be globally unique. And now I want to define the enrollment relation, right? How do I do it? DB, define table, enrolled, okay? And now here I have to say field like student ID, okay? And this is a reference to a student. Okay, then there will be a field, field class ID, okay, which is a reference to a class. Okay, and this is all I need, right, to create a relation between the two. But the interesting part is that I can have additional information associated with a many-to-many relation. For example, I can have a field enrollment date and say that this is a date time, right? So I can remember for every student not only in which class they are, but when the enrollment took place. And the fact that Luca enrolled in 1 to 3 on Saturday, but in 3 to 4 on Wednesday, I mean, is information that is really information that belongs to the relation. One of the tasks that you have to do when you design a database is that you have to figure out to what the information pertains. Does the enrollment date pertain to a student or to a student class combination? And this is why I was slightly unhappy that many of you used the star table. Because if you use the star table was defined having two fields. It was defined as having a post ID and user ID, right? If you do that, it means that a post is not starred or unstarred. A post may be starred by Luca, but not unstarred by Anna. No, the star information is pertaining to the post user pair. Instead, I asked originally in the homework, again, you will not lose points, but I asked that the star belongs simply to a post or whatever it was, a product, right? And so I wanted that every product had a starred information right there in the product. So one of the challenges of when you build your own website is to figure out to what should be information associated. Sorry, to what is information associated with? No, to what? I mean, how to put not the connective at the end. But I think you understood what I mean. So you need to figure out with what information is associated with what other information in a precise way. More precise than when you speak in English with a bit of approximation. Okay? So for example, here, the enrollment date belongs to the student-class relation. But if you have the student and you have a field that means like good standing and is a Boolean, okay, this information actually belongs to a student. The student is in good standing at a particular moment in time. Is not in good standing for a particular class. So you need to do a little bit of this analysis when you create a database. Okay? How do you navigate to these relations? Well, it's basically the same service. So suppose I want to know all the classes in which Luca is enrolled. You simply do DB for row in DB yada yada dot select. Okay? So now the only thing is that I have to figure out what my query is. Okay? So in fact, let me write it in this way. Okay? So that I can put in the query here in all its majesty. And the query would be something like db student name is equal to Luca, or whatever it is. Okay, here I'm using Luca just as a placeholder. Then I write db. Then I need to follow the relation. You know, there is here the table students, there is here the table class, and in the middle there is this table. So I have to navigate from student to enrolled to class. It must be the class in which I got the greatest number of phone calls ever in history. So exactly when I do these databases. So how do I navigate? Then I say db student ID is equal to db enrolled student ID. So you may wonder, you know, is it better that I write it in this direction or that I write it in the opposite direction? db enrolled student ID is equal to db student ID. Well, it shouldn't matter, right? The databases should be smart enough to optimize that. So don't worry about those things. And anyway, I don't know the answer. So then you write db class ID. No, I don't know the answer also because it's complicated. I guess it would depend on which particular database you're using as backend, right? Which may differ for their smartness. So, and also you need to dive into the database. Oh, by the way, it's a terrible idea to call this class, I guess. Like UC class, because class is a reserved word in Python, and so you cannot call something class. db UC class ID is equal to db enrolled class ID. Okay, so this follows the other part of the link, and that's it actually. I think that's all I need to do. And then I can say, for example, print Luca is in, and then I can write like row dot UC class dot name. No? So I cannot simply say row dot name because I'm mixing three tables, and so I have to say first the row name, first the table name and then the column name. Okay? And now I really stop. I mean, I just take questions. But this essentially tells you how to represent information distributed across multiple tables and how to query across those tables following these things that are called foreign keys and that we can think of as pointers. Okay? Questions up to this point? Silence. Maybe the brains have fused. I think, you know, all the calls is because instead I fused my clutch a few days ago, and so this was a dealer telling me that my car is again drivable. Yeah.
When you do reference, is it one-way pointer?
Yes, it's not. I mean, it's not a two-way pointer. If that would be a thing. So if you want to know, for example, I mean, let me answer your question. Again, a good question, by the way, because, you know, all the phone numbers point to the person. But I think your question is, how do you go the other way around? If you know the person, how do you get all the phone numbers? And I think we had an example above. You need to do a query then. You know, this would be an example. Where is it? You know, here I have a row that contains a person. And then, in order to know all the phone numbers of that person, of that address, I have to say db phone address ID is equal to row.id. I have to do a query because there can be multiple results, not one. Does this make sense? Like, what are all the numbers of Luca? Yeah, what are Luca's phones? You see, I need to do a query. Because you cannot simply follow the pointer in the other direction, because there is not only one destination. There can be potentially many, right? The pointer, there can be many records that point to the same record in another table. It's a many-to-one relation. And in fact, I use it as such because I can have many phone numbers.
This thing, like, it doesn't matter if you're being pointed to or you're pointing to something. As down, you have one of them, you can just retrieve both.
No, so it's a many-to-one relation if you go back to your discrete math classes, right? So the relation between fonts and user is a many-to-one. There are many fonts for one user, and so the font table points to the individual user. Okay, and so if you have a many-to-many relation, as you have studied in the good old times of set theory, then you have to implement it by using a separate table. Like if you have a students and classes and there is a many-to-many relation because every student is in many classes and every class has many students, then what you need to do is you need to create this intermediate table that captures the many-to-many relation. Questions, questions? No more questions. Okay. Thank you very much.